In this course, we have learned about a large number of reasoning methods. Here are some of them. We could have added a lot more here, for example, pattern refinement, or logic, or scripts. Typically, when you and I program an AI agent, we pick a method and we program that method into the agent. One unanswered question is, how might an agent know about all of these methods and then autonomously select the right method for a given problem? This is the problem of strategy selection, and metacognition helps with strategy selection. Given a problem, and given that all of these methods are available to the agent to potentially address the problem, metacognition may select between these methods using several criteria. First, each of these methods requires some knowledge of the world. For example, case-based reasoning requires knowledge of cases, constraint propagation requires knowledge of constraints, and so on. Metacognition may select one particular method depending on what knowledge is exactly available for addressing that specific input problem. If for that specific input problem, cases are not available, then clearly the method of case-based reasoning cannot be used. If, on the other hand, constraints are available, then constraint propagation might be a useful method. Second, if the knowledge required by multiple methods is available, then metacognition must select between the competing methods. Another criteria for selecting between these methods might be computational efficiency. For a given class of problems, some of these methods might be computationally more efficient than other methods. As an example, if the problem is very close to a previously encountered case, then a case-based reasoning might be computationally a very good method to use. On the other hand, if the new problem is very different from a previously encountered case, then case-based reasoning may not be a computationally efficient method. We have come across this issue of computational efficiency earlier in the class. For example, when we were discussing generate and test, if the problem is simple, then it is potentially possible to write a generator that will produce good solutions to it. On the other hand, for a very complex problem, the process of generating good solutions may be computationally inefficient. Similarly, if there is a single goal, then the method of mean-sense analysis might be a good choice. On the other hand, if there are multiple goals that are interacting with each other, then mean-sense analysis can run into all kinds of cul-de-sacs and have poor computational efficiency. A third criteria that metacognition can use to select between these various methods is quality of solutions. Some methods come with guarantees of quality of solutions. For example, logic is a method that provides some guarantees of the correctness of solutions. Thus, if this is a problem for which computational efficiency is not important, but the quality of solutions is critical, we might want to use the method of logic because it provides some guarantees of the quality, although it might be computationally inefficient. The same kind of analysis holds for selecting between different learning methods. Once again, given a problem, the agent may have multiple learning methods for addressing that particular problem. What method should the learning agent choose? That depends partly on the nature of the problem. Some methods are applicable to that problem, and some methods may not be applicable to that problem. Second, for example, in this learning task, if the examples are coming one at a time, we might use incremental concept learning. On the other hand, if all the examples are given together, then we might use decision tree learning or identification tree learning. Another criteria for deciding between these methods could be computational efficiency. Yet another criteria could have to do with quality of solutions.